Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Yeah, hello everyone. Am I properly audible and visible? Can you please give a confirmation in the chat box so that we can quickly begin? Apology for the 15-minute delay. There was a bit of technical issue. And also, can you see my screen? I have shared my Google Jamboard. So today will be the session 12 for Graph and Tree series. Yeah, so the students who are present today, hello Rahul, how are you? Hello Ankit, how are you? So can you please write your name in the chat box to mark your presence? Yeah, thank you Rahul. And information technology, what is that Ankit? Yeah, so let's wait maybe one more minute and then we can very quickly start. Meanwhile, what you can do here is that you can write your name of your college and the year in which you are in. Okay, so yes, Rahul, I am good as well. Yes, Rahul, I am good as well. Okay. Yeah, and okay, you are telling your branch. Your branch is information technology. That's great, Ankit. And yeah. One more, I would request everyone to kindly like the live streaming that is going on, and also subscribe to the channel. Okay, we have amazing content which we will be bringing to you all in this Geeks for Geeks practice channel. Okay, so let us start then. So today is the 12th session of our series, and in fact, in the month of December, we had 11 more sessions. So this is the graph and tree session series that is going on in YouTube, and today will be the last of the graph session. And today we will be discussing around two questions. And from the month of January, we will be focusing on tree series. Apart from that, one of other mentor at Geeks for Geeks will be bringing to you a dynamic programming series also. DP series, which will tentatively start from the first week of January. Okay, so this is about the DP series, which will start from first week of the January, and I would request everyone to kindly attend the series as well. And okay, and I will be continuing with the tree portion from the month of January itself. So in the month of January, yeah, so in the month of January, you will be having two classes for tree as well and two classes for DP as well. Okay, so this is how it will continue in the month of January. Yeah, I suppose the video quality is clear. Maybe I just refreshed the camera. Okay, Aravind, you are saying that it is clear and you can continue. Yeah, then that's great. Okay. So maybe Rahul, your internet is maybe a bit slow. I just refreshed my camera and I hope everything is clear now. Okay. So I was telling about January month. In the month of January, we will be having two series, tree classes and DP classes. Okay. So let's talk about today's session. And meanwhile, you can like this live stream as well as subscribe to our channel because we have much more greater content that we are trying to provide. And this will be extremely useful and benefit for all the students who are preparing for their interviews. Okay. So for the newcomers, let me tell you that this session is today we are on the 12th session. So we have discussed variety of topics including the traversal techniques of graph, multi-source BFS, zero one BFS. We discussed about connected component. We discussed about Digestive algorithm. We discussed about zero one BFS, and we did a lot of problems as well. Meanwhile, okay. So you can check out the playlist. It is already there in the YouTube channel. So the thing is that yeah, today we will be discussing two problems as practice problems. So these questions that I will be discussing are very important from interview point of view, and the questions I have previously discussed are also quite famous interview problems. Okay, so this series is basically meant to help you prepare for yourself for your next interviews. Okay, so let us continue then. Let me give you a small introduction about myself. My name is Gaurav Kumar Shaw. Okay, you can find my name in the description of this chat box of this YouTube channel as well. And I'm in my third year, and I'm a third year engineering student at IIT Kharagpur. Okay, so this is an introduction about myself. So let us begin this our session. And meanwhile, you can also check the link for the Geeks for Geeks self-paced course on our website. You will find the link there, and it's an extremely beneficial course, and it's quite beginner friendly as well. So if you're planning to start out with preparation of data structures and algorithm, you can definitely check out this course. It is one of the most best course, and when I was preparing myself, I actually took that course. Okay, so you all can study that. So okay, so we have six people with me available with me right now. So and I would request everyone to kindly stay with me till the very end. We will be having at max 40 to 50 minutes of us, 50 minutes around of our session, so that we can continue. Okay. So the first problem that we will discuss is path with minimum sum. Okay, let me share the screen of the problem statement. Okay, I will also share the link as well. So the problem statement is clear. Okay, so I'm sharing the link as well. This is, let me just copy and yeah, I've shared the link in the chat box. And what you can do, you can just go read the problem statement with yourself. And let's look into the problem statement then. Hmm. So the question is saying that you are a hiker preparing for an upcoming hike. You are given heights, a 2D array of size. So it is a 2D array. It contains rows and columns. So the row and column are given to you as an input. Now the value in each row and column is basically denoting the heights. Okay, height of every row and column. Now you are situated on the top left cell, that is the 0, comma 0 cell, and you have to travel to the bottom right cell, that is the n minus 1, m minus 1 cell. Okay, you understand, from the rightmost path to the leftmost path you have to travel. Now, what you have to do here is that you can either move up, down, left, or right, and you wish to find a route that describes the minimum effort. A route's effort is the maximum absolute difference in height between two consecutive cells of the route. Okay, so let me just describe it to you. This example is also given. Okay, so just read this question properly, and I will be explaining it to you now. Okay, I hope everyone has gotten to the question screen. Okay, so let's discuss this question. What is this trying to say? So you are given a matrix. Okay, this matrix is of size nm, n comma m. So you are standing at this part, the leftmost part. Okay, so the coordinate of the leftmost part is 0, comma 0. It is following zero based indexing, and this part is n minus 1, comma m minus 1. Okay, so this is the rightmost part. Now, your task is to reach from 0, comma 0 to n minus 1, comma m minus 1, such that your effort is minimum. Now, how are we calculating effort? So effort is being calculated is that, let's say you are taking this path. So the effort will be the maximum of all the possible differences that may arise here. Okay, so let's see. Let's say your input graph is something like this. This is your input matrix or the input cells. Okay, so it is denoting the height of every cell. So you are standing on cell number 0 comma 0. It means that you are standing here. So height, that presently you are at a height of 1. Now you wish to go to cell number, this cell. So your height, the height of this cell is 2. So the difference of height is equal to 1. So what will happen? You can go to from here to here with an effort of 1. You can go to here with an effort of 0 because they both are at the same height. You can go from here to here with an effort of 0 because again these both are at the same height. But when you go from 2 to 5, you have to take an effort of 3. So now you have finally reached the node number 5, your destination. It is your destination. So how did you proceed? You went from 1, you went to 2, from 2 you again went to 2, from again 2 you again went to 2, and finally you went to 5. So difference was, initially the difference was 1, then difference was 0, then difference was 0, then finally the difference was 3. So your effort will be maximum of all these differences. So your effort is basically the maximum of 1, 0, 0 and 3. So your effort is equal to 3. Okay, now but this is not the answer. Answer, if you are reaching by this path, then your the effort is 3. But it may be possible that if you reach by some other path, your effort may be less. So of all the paths that is possible, you have to return the minimum, the path with the minimum effort, or you have to return the minimum effort that you will take to reach from your starting node to the starting point to the destination point. Okay, I hope this is clear. Okay, so let us look into it again. Now let's say I am moving from this path. Let's say I am moving from node number 1 to node number 3, from node number 3 to node number 5, from node number 5 to node 3, and again from node 3 to node 5. Okay, so if I'm taking this path, in this case, what will be the difference? Let us see. From 1 to 3 to 5 to 3 to 5. This difference is equal to 2. This difference is equal to 1. This difference is equal to 2. This difference is again equal to 2. So the maximum difference is basically 2. So the effort will be 2 if you are following this path. Okay. So initially if we were following this path, we got an effort 3, but now we have got a better effort. So that is the reason we will take this path. If you are able to find even better effort, then that will be our answer. But in this example, this is the best possible path because you are taking an effort of 2 and it is the minimum possible answer. So you will return the answer as true. Now the question is, I hope everyone has gotten an understanding of the question. Okay, now I'm asking you, what concept you will apply so that you can get an answer for this type of problem. Okay, tell me. Is there anyone who can just briefly write about the concept that you can use to solve this question? We have 14 people with me right now. Anyone? So all I want you all to, it's already mentioned in my slide that we will be using Digestive algorithm. But anyone can just write briefly that how can we apply the concept to solve this problem such that we get the minimum. Okay. And one more thing I did not mention here is that if you're standing on any given cell, you can only move in the 4 direction. That is right, left, top, and bottom. You cannot move diagonally. Okay, so if you're standing at, let's say, if any cell, you will have only 4 possible movements, and of those 4 possible movements, you're supposed to choose any one of the movement and then proceed further. Okay, so this is how. In fact, this type of graph question we have already discussed previously. Question that involved about. Got it. So anyone, any idea how we'll apply the concept of Digestive algorithm? Yeah. So let's say. Okay. So let me tell you one thing that you all know what exactly the Digestive algorithm. Digestive algorithm was helping us to find the shortest path from any given node to all the other nodes. For example, we had a starting node and we were trying to find the shortest path for every other node starting from the starting node. So initially, what we used to do, we used to take a priority queue, and in the priority queue we used to push the distance and the node number. Okay, and inside the priority queue used to be of the min heap type. So what happened? Whatever distance which was the minimum value will be on top of the priority queue, and we used to process that. And we also used to maintain a distance array. Why distance array? Because distance array would help us keep track of the distances. But the thing here is that it may be possible that the distance array which you are taking, so it will keep track of the distance array. And if at any point of time you are able to find a better distance to reach any given node, so you will update that in the distance array. So this was the entire idea of Digester's algorithm. Okay, so in this case also we will be maintaining a priority queue and Digester's algorithm. Why a Digester's algorithm? Because let's say, because we need to minimize our effort. Okay, so in Digestive algorithm, what we were doing, we were minimizing our cost. Okay, the weight. Okay, so that is the reason every node has a edge, and every edge has a weight. So in our path, we were trying to minimize the total weight. So what we will do, that is the reason we are keeping a distance array. Okay, and initially we are initializing the first value as 0, because the cost to reach from this point to this point will be 0. So after this algorithm is over, whatever value is stored here will be the minimum possible value to reach our destination. I hope you all got this. Now the thing is that what we should keep in our priority queue. Okay, so what we are trying to maximize and what we are trying to minimize. Let's see. We are not trying to maximize anything. We are trying to minimize our effort, and our effort is equal to the maximum of all possible differences that there exist. Okay, so what we will do here, we will let's say which is standing on the first node. We will go to its neighboring node, this node and this node. And what we will do? We will compute the difference. Let's say the difference was 1 year. So inside the priority queue, I will push the difference value and the node value. Okay, the node value will be 0, comma 1. Okay, so this is difference 1. And if I'm going at 3, the difference will be 2. And again, the node value will be 1, comma 0. Okay, now this since priority queue is of min heap type, the difference with the minimum value 1 will be on top. Now if I again process this value, okay, now I see that the difference value is 0 for the next case, but my difference value is already 1. So since I am taking the maximum of all possible differences in a graph, I will keep my difference value as it is. So if I am able to see a difference value which is greater than the previously computed difference value, I will take that value, because we are trying to take the maximum of all the differences. But if I see a difference value less than its previous value, I will do nothing. Okay, I hope you all understood this concept. Hello Nikaj, how are you? Okay, today we are doing a problem related to digestive algorithm. I have already pasted the link of the problem. You can just check that out. Okay. Okay, so let us see look into this. Hmm. Okay, so where I was talking, yeah. So that was the reason. I hope everyone got the idea that why we are taking that. Yeah, at every point of time we are taking the maximum. So we will only consider a difference if we are able to get a difference value greater than the previously computed difference, and then we will push it into the priority queue. But if not, I will keep the difference as it is. Okay, so this was the idea. And whenever we are reaching our destination, okay, let's say I reached a destination, this value, and what I will do, I will first if I am able to reach a destination, uh, but let's say I am standing on this node. Okay, and I reached my let's say I'm standing on this node number row is equal to 3 and column is equal to 1. So if I'm standing on this 3, okay, now I am able to reach to node number 5. Okay, okay, so I'm able to reach node number 5 in that case. Okay, so I'm able to reach node number 5. Now, when I'm reaching node number 5, I know my difference, I know my cells, so I put that in my priority queue. Now, when I again come back to my priority queue will give me the minimum of all the possible there. So, if I'm again able to see that I'm standing on my destination, there is nothing to proceed. So, in that case, I will just return my answer because I have already found the minimum effort that it will take. Okay. So I let us look into an implementation of this concept. Hello Avinash, welcome. So we are doing a problem related to Digestive algorithm today. You can watch it. I have pasted a link of the problem in the chat box. You can have a look at it. And so I discussed about. So let's look into the coding implementation. So we are given only one vector, a vector which contains height. So first of all, what we do, we try to calculate the int n and int m. So which is the row size and the column size. We then create a distance array, and we initialize it with infinity, that is integer maximum, that is 1e9. Okay. After that, what we do, we declare a priority queue. After that, we declare a priority queue of min heap type. Okay, so this is the syntax, and in our priority queue we are putting three things. The first is a the first is my difference, the value of difference, and the second is my coordinate. So coordinate is represented in the form of a pair. So what I am, the data type will be, as you can see, the data type will be something like this: pair, pair of integer comma pair of integer comma integer. So we are keeping two values in a pair, and the second part of the pair is also another pair. So the second part is containing the coordinates, and the first part is containing the difference. Now we have previously done this type of problems when we were used to whenever we are doing a problem related to a matrix, and we need to move in four directions. So these are the distance arrays. So this array will help me go across all possible four directions when we were trying to do our program. Then what we do? We write a priority queue. So we continue our digestive algorithm as long as the priority queue is not empty. We take the top element from our priority queue and we pop that out. Now we have to calculate a difference. So the distance will be the first it dot first, because that is the difference element, right? The second will be the row and the column. Okay, the point in which we are basically going to standing right now. The point, the node which we took out from the priority queue. Okay, so we have the distance, we have the coordinates. So by dis, the variable dis basically means the difference calculated till there. Now what we will do, we will let's skip over this portion right now. Okay, so what we will do, we will go across all four possible directions that there exist. So in this case, we see that and the traversal of all the four directions is possible only with the help of this distance array. So in the distance array, what we do, we go across all four possible directions. Okay, now when we are going across all four possible directions, so we will first check. The first thing that we will check is that whether it is a valid distance or not. If it is a valid point, it means that it is well within the our matrix. If it is well within our matrix, I have to know that whether it is a valid path to move or not. If it is a valid path, in that case, what we will do, we'll calculate few things. The first thing will be the current distance. The current distance will give me the height minus the current height, the height of the row in which I am trying to go minus the height of my present row, and we will take the absolute value. So this will give me the current difference. Now we will take the maximum, because at every instance, every path, we are trying to take the maximum of differences, right? That will be our effort. So that is the reason we are taking max dis. Okay, now max dis will be equal to max of current distance comma distance, right? This is done. After that, we will see whether this max distance is less than the distance we have recorded in our distance array. Because what we are doing, max distance is nothing but the effort it is taking to reach at that point under consideration. Now we are seeing that now what we have to do, we have to minimize our effort. So that is the reason we are checking that inside our distance array, is it a greater value than what I have? So if it is a greater value than what I have presently, in that case I will update it, because I want to minimize my distance. So right now I have, so it means that presently I am inside a path which is basically giving me a better value of effort or a lesser value of effort. So in that case I will update my distance array. So this distance matrix got updated with the new value. And what will I do? I will just push the new value into my priority queue. Okay, I'm keep on doing this. Now let's say I reached my destination and I pushed my destination into my priority queue. Okay, now what will happen? If what will happen, my priority queue is always giving me the minimum distance, right? And we want minimum effort. So of all the values which are inside my priority queue, my destination comes out to be the minimum. In that case, what will happen? I will just return my answer. I will not wait for my priority queue to be declared as empty. So what will I do? I will just, if r is equal to n minus 1 and c is equal to m minus 1, I will just return before I am even proceeding to go inside this for loop to traverse across all the four paths, because it makes no sense. I have reached my destination, and my priority queue is giving me my destination. It means my priority queue is actually giving me the minimum distance that is possible. It is giving me my destination. So why again go to a process four path? Because in that case, it won't work, right? So this is how it will be. So let us submit this problem and check whether it is correct or not. Yeah. So as you can see, all the test cases have passed. So therefore, this problem is correct. Yeah. Any doubts here? Hello, Naikaj, are you there? Hello, Rahul, are you there? Hello, Ankit. So I hope everyone understood this problem. If you have any doubts, you can write in the chat box and I will be very happy to clear them. Okay, then let us proceed to the next question then. So this was the question called path with minimum effort. This is solved with Digestive algorithm. Okay, so now let us look into the next question. Now this question is called flood fill algorithm. Okay, so let me share the screen. Yeah. So okay, thank you, Aman, for your kind words. So let's. I hope you understood the previous problem. So let us work. Let us look into this problem. This is quite a famous problem. This Sturteville algorithm, and it is asked very, very, very frequently in interviews. Okay, and it is a very famous and very common interview question. As you can see, 66,000 people have solved this problem on Geeks for Geeks. Okay, so there are 66,000 submissions of this problem, and it is a medium level problem, but this is very, very famous problem. So, and it's quite easy as well. Okay, so let us look into it. How is this working? Okay, so let us see what the question is trying to say us, and we'll proceed then. Yeah. So let's have a look here. Now in the question it is saying that there is an image which is represented by a 2D array of integers. Each integer is representing the pixel of an image. Okay. So this is also a problem in which our graph is given in the form of a matrix. Now we are given two coordinates, SRSC, which is basically the source representing the starting pixel of the row and the column. Now of the flood fill. Now basically what is happening, and we are also given a new color. Okay. So you see, this is our image. A vector is given as an image, and we are given a starting point, the source row and the source column, and we are also given a new column. Now we have to perform an operation called flood fill. In this flood fill, what happens? We consider the starting pixel plus any pixel connected in the four directional to its starting point. So what we will look out? We will look out for all the four directions, pixel in the four direction. Okay. So plus any so if they are of the same color, so what we will do, we will replace the color of all the aforementioned pixel with a new color. So let's say I am standing at a pixel of color 2, and I will check all the four direction, and I'm able to find few pixels of the color 2 itself. So what will I do? I will change both of those color to color 3 if my color 3 is the new color. Okay, so this is what we will do. So let us look into an example and try to understand this. We will just take the first example. So let me write the first example on my screen. The first example, 111, 110, and 101. Hello Nandu Krishnan, how are you? So I'm sharing my tab here. Okay, so according to the first question, okay, so this part, the first question contains 111, 110, 111, 110, 101. Okay, so this is it about the first part. Huh. Now the thing is that we are given this question. Okay. Now our starting point is also given as starting point is given as 1 comma 1, and yeah. So in the question it is mentioned that our starting pixel values will be from 0 to 10, and nm the constraints are 1 based indexing. So when it is mentioning 1 comma 1, it means that I am standing on this index, this point. Now basically I see all the neighboring elements. I see this neighboring element, I see this neighboring elements, because I can only proceed in the four directions. Okay, so these are the two neighboring elements. Now the condition is if the neighboring elements are same color as the initial element. Okay, so color is same of the neighboring elements and of the initial elements. I will update all those color to the my new color. So I also have a variable called a new color which I have gotten as an input. Okay, so what will I do? I see these are new colors, so I will just update them to our new color is 2. So 221, 220, 101. Okay, this is done. Now what will I do? Now the question is asking me, but is my operations over? No, it is not over. Why? Because I will again come to the next point. Okay, I come to this point. Okay, now my new color is basically this. Hmm. Okay, now I come here and I see that the neighboring colors, here it is 1 and here it is 2. But the initial color of this was 1. Okay, so what I will do, I will update this color to 2 as well. So now my graph will look something like this: 222, 220, 101. Now again I will come back here. I come to here, this node. If I'm processing this node, I see that this is 1. But initially this was 1, so both the color were same. So I will update this value to 2 as well. So finally my graph will look something like this: 222, 220, 201. And but there is no way I can change this one, because this one is connected to zeros. Okay, and so I can only change this one had it been these two. Either of these would have been 1. Okay, but I am unable to. So this will be our answer. Okay, so this is what we have to do in this flood fill algorithm. I hope everyone understood it. Okay, hello Aman, are you there? Hello Nandu, Naikach. So is the question clear? So can anyone just briefly write in the chat box that what we are going to do that will help us solve this question? Like yeah, this is a flood. The question is flood fill algorithm. Okay, so this operation of changing the colors is called flood fill. Okay, this is just a name of the question, Ashish. Okay, thank you, Vishal. Okay, so now what exactly are we going to do here? Any ideas, anyone? Okay, so listen to my approach very carefully. So what we will do, in order to perform this operation, we will consider our starting pixel plus any pixel which are connected in the four direction to the starting pixel of a same color as the starting pixel. Okay, so what we will do basically, we can either do a breadth first search or a depth first search from any given pixel. Now we can follow BFS also, but at this point of time, let us help do with the help of DFS, because writing DFS code is quite cleaner in nature. Okay, so the algorithm, the steps of the algorithm which we will follow will be something like this. We will put a DFS call. We will start with the starting pixel and make sure to store the initial color. Okay, so we have to keep our initial color in a new variable. Okay, so I'm explaining here only. Let's say I'm starting with my starting pixel and I'm keeping the new color. So I'm declaring a new variable called initial color and I'm declaring it as one, putting the value as one because my starting color is one. Now what I do here is that I create my yeah. So basically I have my one. So what I do, I I can basically replace the color on the same matrix, but or else what I can do, I can create a copy of the given matrix. Okay, so let's say I create a copy of the given matrix, and what we do, we check the neighbors. So when we are checking the neighbors, and then we see that the neighbors has the same as the initial color because we are storing our initial color as the in a variable. Okay, so why we are storing that? Because in the process of changing, I will change the initial color because the one will become two, but I need to know that initial color was one. Okay, because later in our traversal, we are changing all those colors which are equal to the initial color. Okay, got it. So that is what we are doing. So after that, what we will do, so we can either use the same matrix to, yeah. So this is what we have done. So we go across all the four direction and check for the unvisited neighbors. Okay, we are keeping a visited array as well, and we are unvisited neighbors of the same initial color. It should be of the same initial color. Now, in order to travel the four directions, we just saw in the previous example that we were able to travel all the four directions using a distance array. So we will do the same here also. We'll keep a distance array and it will help us travel all the four directions. So in the DFS call, what we will do, we will start with unvisited neighbor, color all the pixels that have the same initial color, and at the same time, we will also mark them as visited. In this way, we will be able to color all the pixels which have the same color and we will be able to perform the flood fill algorithm. So this DFS traversal will help make us do that, right? Because what happens in DFS traversal, we start from a node, we go to its neighboring nodes. Okay, then again the DFS function get called for the neighboring node and will keep on getting called until and unless it is not able to find a node, and then it will come back. So this is the process, and meanwhile it is marking it as visited. So after the DFS traversal get over for all the cells, we will be able to successfully color my entire array. Okay, so let us see how we will do it. Okay, so any doubts here? Okay, Vishal is saying BFS. Yes, Vishal, we can apply BFS also. It's just a choice of which algorithm to apply and which you think will be easier at that point of time. So the first step is to take the initial color. I'm storing the initial color in a variable called ini color. Okay. After that, what I'm doing, I'm creating an answer vector. Okay, and I'm making a copy of my given image on this answer vector. I don't want to change my given image vector. Okay, it is better to always create a copy. Now this is my distance array just from like the previous example we saw, previous question which we did, and we have done similar type of questions. Whenever we want to traverse in four direction, we will declare a distance array. After that, I have to now write the DFS code. Okay, so DFS, how will the DFS code look like? So what I'm sending in my DFS code are few parameters. The first parameter and the second parameter are the coordinates. Okay, the coordinates of my starting point. So initially I'm sending SC and SR and LC, the starting point. After that, I am also sending my answer vector, my image vector also, image vector of vector, my answer vector of vector, sending the new color in which I want to color those cells which has the same as the initial color, sending my del row and del col because this will help us to travel across the four direction. I'm also sending the initial color also. Okay, so this is how I'm doing. So whenever we are entering a DFS, our first step would be to color that thing. Okay, so we are basically coloring that row and column as the new color. Okay, after that, what we are doing, we are taking our size n and m of our given matrix. We are traveling in the four directions. The first step would be to check whether that is a valid direction or not. Then we will check whether the color of that cell is equal to the initial color or not. If it is equal to the initial color and in the answer vector it is not equal to the new color because I want to change it to the new color, right? So if it is not equal to the new color, what will I do? I will again do a DFS call for that particular cell. And when I am doing a DFS call for that particular node, I will again mark that answer row column is equal to new color. Okay, so after this DFS function is a recursive function, so that is the reason we are doing so. So after this, the DFS function gets called for the starting node, and after this function gets implemented, we will be able to return our answer because it will store the answer. Okay, So this is how we are doing. And the idea of we also discussed about keeping a visited array, but the idea we are just putting a check here that if in our answer vector if it is not equal to the new color, it means that it is an unvisited. Because if it has been a color which is equal to the initial color and it is not equal to new color, it means that we are going down a DFS path, a successful DFS path, in which I should change. So let us submit this problem and check whether it is correct or not. I am pasting the link of this question in the chat box itself. So, do you have any doubts related to this? Okay, so as you can see, all the test cases have passed, so therefore this question is correct. Any doubts related to this question? This is quite a famous question, and I would request everyone to kindly understand this question very well. Okay, so we have successfully solved two questions in the session. So, how did you like? So, did you all like the session today? Hello, Naika, are you there? Hello, Vishal. Hello, Ashish. Hello, Nandu. Hello, Aman. Hello, Avinash. So, yeah, and let me tell you more about this session. So basically, today will be the very last session of this year, in fact, and of in fact the graph series as well. And after that, yeah, and we will be continuing our tree series from January onwards. So you will see that whenever we are starting, you will see it is scheduled. It will mostly start from the 3rd or 4th of January. Okay, so we will be studying or doing our tree series, and it will be on 10 p.m. itself. Okay, so yeah, this is it then. And after that, what we can do basically, yeah, and I would request everyone to kindly like the session and subscribe it as well, because from the month of January you will also see a dynamic programming series coming up on this channel. Okay, and one of my colleague at Geeks for Geeks will be taking up this session for dynamic programming. Okay, and which will also be around 2 days a week for the classes for session in the month of January itself. Okay then I hope it's great then. Then yeah, so tomorrow and the day after tomorrow will be holidays probably, and this is the very last session of this year. So I wish you all a very very happy New Year, and all the best for your internship and placements which you will be having, upcoming internships and placements. And kindly subscribe to our channel. We will be providing a lot of content which will be helpful for your upcoming interviews. And yeah, thank you, Aman. Uh, that's quite a lot of kind words then. Yeah, and apart from that, yeah, all the best for your preparations and enjoy your holidays as well, and have a very very happy New Year also. Yeah, then bye bye. Good night. Yes, Aman, you can ask a question. I was just about to end the session, but I saw your comment. Yeah, what would you like to ask? How many days for graphs? So today was a 12th session in fact. So we discussed about so a total of 12 session in Geeks for Geeks. So is this a question? How many days for graphs? So like we had 12 sessions for graphs, and we will also have 8 sessions for trees as well. So a total of 20 sessions over 2 months. And I have discussed quite a lot of theory as well and questions as well. But now after that, after you have a look at the sessions, there are a lot of practice problems as well, which you can take help. Yeah, on the Geeks for Geeks platform, what you can do, just type in Google Geeks for Geeks practice and just write graph. Okay, so when you write that, you will get a lot of easy questions, medium level question, hard level questions, and you can practice those questions. Okay, so those are very popular interview questions which you can do. So yeah, this is it then. How many days does it take to solve easy and medium questions comfortably? Like it will, it depends upon your practice, but I hope, but I am sure that in 1 month time you can basically have a very good grasp of graphs. Okay, you can after you solve like 30-40 problems, you can very easily have a good grasp of graph concepts. Okay then, yeah, man. Thank you a lot. Welcome, and yes, a very good night to everyone, and a happy New Year as well. Bye bye.